So we've covered the topic of perpendicular bisectors in the previous video. What I'm going to do is I'm going to pose you a couple of questions here about finding perpendicular bisectors. I want you to go away, have a crack at them, then come back and check your answers with the solutions video. So here you go. The question is quite simple. Let's find the perpendicular bisector of these three pairs of points. So the first pair is A at 3, -3 and B at -1, 9. Your second pair is C at 4, 6 and D at 10, -2. And your third pair is E at 4, -10 and F at 8, 2. Find the perpendicular bisectors of each of those. Come back and check your work. Good luck. So in the previous video I set you a few questions on calculating perpendicular bisectors. What I'm going to do in this video is I'm going to work you through the solutions and show you how you'd approach these types of questions. So a quick refresher for you. This was what I asked you to do. Find the perpendicular bisector of these three pairs of points. So point A and B in part 1, the C and D for part 2, and E and F for part 3. So let's have a look at these. Now, a couple of key things you need to remember when I'm talking about perpendicular bisectors is first, that they're perpendicular to the line that you've got, and second, that they're bisectors. So remember, perpendicular, there's a certain property we want to bring into play and use here, where M1 times M2 equals -1. So the product of the two gradients is -1 if the two lines are perpendicular to each other. And the other one is the bisector part. What that means is that it just cuts it in half. Alright, so bisector cuts it in half. So if I've got a line like that, joining those 2 points, my bisector cuts it there, and I've got the same distance on either side, the same length. So that's what we need to do. So first thing we need to do is to get where it cuts, which is find the midpoint of these two. Then it's find the gradient of my line, which I need to use this property here and the gradient of this line here. So let's start with that. So let's start with the gradient of AB. So we know the gradient of AB, 9 take away -3 over 1 take away 3. 9 minus -3 is the same as 9 plus 3, which is 12. 1 take away 3 is -2. So my gradient there is -6. So that's the gradient of AB. What I need to remember is that M1 times M2 is equal to -1. So -6 times the gradient of my perpendicular bisector is equal to -1. So from that I can get that my perpendicular bisector has a gradient of 1/6. Excellent. Now I just need a point on the line, which is the midpoint of these. So what I need to now do is find the middle of each of them. So I just add the two parts. So in this case for x it's 3 plus -1 and then half them. And the same for the y. So it's -3 plus 9 and then half them again. 3 plus -1, plus minus is take away, so 3 take away 1 is 2, 2 divided by 2 is 1. -3 plus 9 is 6, divide 6 by 2, and you get 3. So there you go, there's my midpoint, so the point where the bisector, the perpendicular bisector, cuts that line. I now have enough information to get the equation. Use my formula for the equation of a straight line, y minus b equals mx minus a, and just put the values in. So I get y minus 3 equals 1/6 bracket x minus 1. Now again, remember, we can rearrange this in a couple of different ways. What I'm going to do is I'm going to rearrange it in the ax plus by plus c equals 0 form. So to do that, I start by multiplying out. So I get 6y take away 18 equals x minus 1. And from that, I can say 6y minus x minus 17 equals 0. That there is the form of the equation of my straight line, my perpendicular bisector of these 2 points. Second example, we need to follow the same general steps. We need to know the gradient, then use a gradient property, then we need the midpoint. So let's start with the gradient. It's the gradient of CD. So in this case, it's going to be 6 take away -2 divided by 4 minus 10. 6 minus -2, well, minus becomes a plus, so 6 plus 2, which is 8. 4 minus 10 gives you -6. So my gradient here is -4/3. I then want to use m1 times m2 is equal to -1 to find my other gradient. So I know that -4/3 times my perpendicular bisector's gradient is equal to -1. From that I can say fine, so my perpendicular bisector has a gradient of 3/4. Now I need to find the midpoint of CD. So again, it's just add up the x parts, add up the y parts, and average them out, find the midpoint of them, divide it by 2. So for the x parts, I've got 4 plus 10 divided by 2. And for the y parts, I've got 6 plus -2 divided by 2. 4 plus 10 is 14, divide that by 2 and you get 7. 6 plus minus 2 is the same as 6 take away 2, which is 4. Divide that by 2 and we get 2. So my midpoint, where the perpendicular bisector meets the line, is at 7, 2. I've got the gradient and a point, plug them in the formula. So I get y minus 2 equals 3 over 4, my m, bracket, x minus a becomes x minus 7. And then it's just a case of multiplying it out and getting it in the right format. So 4y minus 8 equals 3x minus 21. And again, I'm going to just shift it all to the one side. 4y minus 3x, add 21 to both sides, plus 13 equals 0. So there you go, equation of a straight line in this case. Last one I asked you to do, again, same general format and same way we need to approach a question like this. First find my gradient of e to f. So y1 minus y2, so negative 10 minus 2 over 4 minus 8. Negative 10 minus 2, that gives me negative 12. 4 minus 8 gives me negative 4. Negative 12 divided by negative 4 gives me 3. Then we use our perpendicular gradient property. So m1 times m2 equals negative 1. So in this case, 3 times my perpendicular bisector gradient is equal to negative 1. So my perpendicular bisector has a gradient of a third. We then find our midpoint of the 2 points. So add up the x's, divide by 2, so 4 plus 8 divided by 2. Add up the y's, negative 10 plus 2, and divide it by 2 as well. 4 plus 8 is 12, divide that by 2, we get 6. Negative 10 plus 2 is negative 8, divide that by 2, we get negative 4. So there you go, there's my midpoint where the perpendicular bisector meets the line here. All I do now is plug it all together. So y minus b becomes y plus 4, remember minus minus becomes a plus, equals negative a third, bracket x minus 6. And then it's simplifying it all. Get it all to the same side again. We get 3y plus 12 equals negative x plus 6, and then shift this all over here. Doing that, I get 3y plus x, take away 6 from both sides, so I get plus 6 equals 0. There you go. Equation of that straight line there. So that's how we get the perpendicular bisector. Same general steps. Find the gradient, use the perpendicular gradient property, find our midpoint, then use our equation of a straight line. Hope it went well. See you in class for some more work.